Hello guys, today I'm going to show you how C++ compiler works and what are the interpreters and the compilers are. So it is most important topic because everyone should know what are compilers and what are interpreters and how compiler works in C++ because most of the students know how to code and they are very talented in coding, but they don't know how C++ compilers work, what is happening behind the scene. So today I'm going to show you how C++ compiler works, what are the interpreters, what are the compilers, what is the difference between these two. So let's start. So I have an example that an interpreter translates the source code into the activities and immediately executes those activities. Basic, for example, has been a popular interpreter language. Traditional basic interprets translates the execute one line at one time, and it makes things more slow than the compilers, since they must be translate any repeat code. Basic has also been compiled for speed. More modern interpreters such as those for the Python language. Python is the most famous. It's interpreter language. Translate the entire program into the immediate languages that is being executed by the much faster interpreter. Interpreters have many advantages. The transition from writing code to executing code is almost immediate, and the source code is always available, so the interpreter can be much more specific when an error occurs. The benefits often cited for the interpreters are the ease of interaction and rapid development of programs. Interpreted language often have server limitations. When building large scale projects, we don't often use the interpreted languages for the large scale projects. Always the use of compiled languages for the large scale projects is more good than the interpreted languages using it in the large scale projects. So must interpreter must always be in the memory to execute the code, and even the faster interpreter may introduce the unacceptable speed restrictions. More interpreters require that complete source code be brought into the interpreter all at once. So interpreter always read code line by line. It makes something slower. So the compilers are completely different. Compilers translate the source code directly into assembly code. It will translate the entire code into the assembly code. So or the machine instruction, eventually the end product as a file or file construction machine code. This is an involved process. This is usually takes several steps. The transition from writing code to the executing code is significantly large with a compiler. So depending on the acumen of the compiler, written programs that generated by a compiler tend to require much less space to run. It requires much less space to run than the interpreters. So separate compilation has many benefits. A program that taken all at once would exceed the limits of the compilers. I mean that all the code executed at once, they can exceed the limits of compiler, or the compiling environment can be compiled into the pieces. Program can be built and tested one piece at a time. Once a piece is working, it can be saved. It can be treated as a building block. It is total building block collection of tested and working pieces can be compiled into the libraries for use by others programmers. As such pieces a piece is created, that when I will compile, the piece will be created, entire code will be into the one piece. The complexity of other pieces is hidden. All these features support the creation of large programs. Okay, so now I'm going to show you how C++ compiler works. So I'm going to close it, open the Visual Studio again, file, new project, empty project, give it any name, for example hello world. Okay, I'm going to add the file here, the cpp file .h file. I will cover these files in this video also, so I'm giving the name main.cpp, click enter. So I'm going to include a file iostream. I will cover these files also. I will cover, these are the preprocessor directives. I will cover this topic in this video also. So I'm going to write the code in main c std cout hello world. So std extraction operator, forget here. So this is the main code. The main function is the entry point here. So I will build it. Let's build it successfully. Run it. It's running. Look at that. It's printing it correctly. I'm saying that the main function is the entry point here. Main function tells the compiler to start the execution from here. Okay, when I will change this, look, I change the spellings here. Main spellings. Okay, MIAN. Okay, I change the spellings here. Here's a function. It should be all right, but it's not right. When I'm going to compile it, look at that. It showed me an error that entry point must be defined here. The entry point is not defined. The compiler doesn't know where I should start the execution of the program. Is written in a text shape. It's totally a text shape. It's a totally we are writing just in English code, but we don't know how the compiler taking it and converting it into assembly language, into a machine code. So we should know how it is working. So I have a picture to show you. This can explain better. So compiler takes it .c language .h header file .cpp .hpp. This is the header files in the .cpp. Compiler is known that so compiler is taking these files and converting into the object files, and the linker does those two steps of running the program. A linker takes it and converts into the executable file. Linker is another topic we will cover into the future. I will cover it in the future. So linker converts into the executable file. Compiler takes these files, converts into the obj file, and the linkers takes them and converts into the executable file. Okay, so I will change the correct it. So I will build it. I'm building it. So it's created successfully and it's running also. So I will go to the project directory. What is the project name? Hello world. I will go to the debug. Here the executable file is here. So I will run it. Look at that, is running correctly here. From here the executable file is running correctly. So go back into the compiler. So I will discuss these things. What are these things? How compiler does with these things? When I'm writing code hash include iostream, the compiler takes all the code from this file and paste it here, from this file and pasting it here. So I can show you. You can add I'm going to add the header file, .h file. I'm getting it the end brace and brace. Okay, and brace .h with the .h extension is compulsory. So I'm writing only the end brace here. So we write the embrace.h in just the embrace here. Okay, so in this I will include here and include embrace .h capital E. So we are going to compile build it. So it's built successfully. So I'm going to run it. It's running successfully here. Look at that. So what it does actually does, the compilers look for these files, go here and copied it, and just copy it and just paste here. So you should know now all about how the header files are working, the preprocessor directives are working in this. The same is the case with these files. Include what it's doing. It is iostream is a header file, and it is doing all the code in iostream. Look at that. The code in iostream is doing is copying all the code and pasting it into the main.cpp, and we are using the data the iostream is containing in our actual file is underneath this. So that's all for the compiler, C++ compiler working. So all you should know, there's these things. So this x86 is mean that at x86 that your program as you are writing is going to run on 32-bit operating system, 32-bit machine, and x84 means that program you are writing is going to run on 64-bit machine. The modes are here, the release mode and the debug mode. We are just working with the debug mode. We have to work, we don't have a concern about the release work here. So that's all for this.